before. I know the underlying population percentage, 0.6 divided by 30. That's what you find. And what you would find, I gave you the population percent. That's why it'd be better to use the population percent, because I gave you Chicago's population percent at the time. 99% means 2.57 rather than 1.96. And it's some number. But you set it up, and you'll find that sort of, you explain what the confidence interval means, then explain how the percent African observed might be so different from the city percentages. And there's two things you could say there, since you don't actually know about Chicago. You could say, and once again, your 99% confidence interval is going to give you some confidence interval that goes from like, whatever, 72 to 88. It's not going to get close to 40. So first of all, you get a confidence interval that doesn't get anywhere near 40. Which, even without doing a kind of hypothesis test, which I haven't asked you to do, you would immediately know that either this area of the city is different, or I just had, and it's almost unimaginable that I just had an incredibly unusual day if I was going past a random sample of people in Chicago. And so we would go, probably the south side is a little bit different than the rest of the city in average percents. That's the finding you should find. Essentially, you're going to find, I'm 99% confident that the true percent in that area of the city is somewhere between 70, 75, 72, and 88. I'm going to calculate it, but somewhere in there, and which is nowhere close to the 40. So the one unlikely choice would be that I just had an extremely rare day of lightning with sample 30. The more likely, and the better sort of answer would be, no, you're just in different areas of the city have different percents, and you're just in a different area of the city. That's the best. That would be the best, better explanation. Given once again that the city was 20% Latino in 1991, how likely would it have been for me to randomly meet 4 or less non-Latinos in a random bike ride past 7 Chicago residents? What does that question sound like? Remember what we did a few weeks ago? Which was it called? The binomial distribution, right? So you heard that, you think, okay, the underlying, I don't think you brought my table with me, but the underlying probability of Latino is 0.2, or the Latino, not Latino, Latino complement is 0.8, those are 2%, and now I'm looking at the 7. And I'm looking, how likely would it have been to meet 4 or less non-Latinos? So if I want to use this percent, it would be 4 or less non-Latinos, which would be 4, 3, 2, 1, or 0 non-Latinos. Probability of non-Latinos 80%, and a 7. And once again, remember how we could do these either with an individual table, and you'll have these tables for the exam. You could either add up the individuals, or you could... Now, 4 or less is harder, a little trickier to do with the table, but you could add 4, 3, 2, or 1. Because our tables, remember, go this number or higher. So, the complement of what? If you have 4 non-Latinos, what's that? 3 Latinos. 2, 1. Let's do 3, 4, 5, 6, or 7 Latinos. Four or less non-Latinos would be the same as 3 or more Latinos, right? Essentially, just like with initial probabilities, with binomials, you always have a binomial, then you have its complement. I don't have the table with me. But that's how, first you diagnose, okay.
Do you want to?
Because I'm going to move on, because I don't have so much time. But that'd be, you go to that, and then you go to your table, and you figure